Good morning po.
Morning po.
Good
Good
morning
morning
po.
po.
Happy Valentine's Day po.
Happy
Happy
Valentine's Day.
Aspen's Day and everything. Yung mga ano dyan, pagkatapos ng klase, sisibat na sa date yan.
Buttermilk.
Sisibat na sa date. Sana all. Okay, so, ano, nasa na tayong sa ano? Hindi ko na alam eh.
Slide
Ano?
29 po.
Slide 29, Module 1, tama? Module
Yes
2?
po. Module 1.
Module 1. Parang Module 2 na. Kasi
Opo
ang
pala,
module,
module 2 po.
Module 2, ano? Ayan. Sige, sige. Saglit lang. Before we start, mag-attendance muna tayo ha. Saglit lang.
Fifth one, electricity produced from light through the photoelectric effect and through the use of solar panels.
Okay, so nandyan si Mr. Angeles. Tama?
The electricity produced from
At
Yes po.
si
yan yung mga ways or methods.
Miss Manalo. Tama po ba?
In order to generate electricity. So, next natin, ano na tayong quick video. So, bakit ba natin siya kailangan electricity? Kasi nga ang ating
Sevilla.
electricity ay all about
Nandyan na din.
sa flow ng ating electrons sa ating system. So,
Okay.
ito yung ating
So, kayo ay
basic
50. Ano? Ang dami.
So, within this basic structure,
Kayo ang pinakamaraming
meron tayong
number of students. Ano? 2205.
So, ating quiz siya ay
Okay, so let's start.
electrons.
So, have you seen Module 3 in your Google Classroom? Chapter 1, Module 3. Nakita ba? Ayan. So, nag-upload ako. Ano? This one, Chapter 1, Module 3. So, you will get all the formulas there and put it in your index card or in your notebook or somewhere down the road. Okay? Because I will check it next week. Next week is because last week we didn't get a chance to see each other because we don't have class that day, Friday last week, because it's holiday that day, So next week, I'm going to meet you and I will check all your index card and dapat ay kompleto, complete formulas from Chapter 1, Module 1, Module 2, and Module 1 yata wala naman. Wala namang formula doon. From Module 2 to Module 3. Okay? All the formulas there, put it in your index card. Okay? So, yeah. Let's start. Slide 29. Nakikita?
Closure ng ating
Opo.
29.
remove lang po ang ating
Okay, so
electrons
magnetic
once
forces
applied
na
by
tayo. Ano?
or by the voltage.
Wait a minute, I'm gonna get my pen tablet.
To the flow of our electrons or yung ating mga
If you have any questions, just raise your hand and I'm gonna
sabi ko kanina, no? Electrons in the
answer
outer
it.
rings
Oh
of
my
or
God.
shells of an atom
Ayan.
are bound for very much either
Pag hindi po lumilipat ang slide, just tell me, okay? And if nagpuputol-putol na ako, nagro-robot na ako dito, sabihin niyo ha. Okay, so magnetic forces. So force between two parallel conductors. So this is an example of two parallel conductors. Now, when we say parallel, ano yung pumapasok sa isip niyo pagka parallel?
with a mass of for about
Hello?
9.737
Magkatapat po.
Magkatapat or yung hindi sila nag-meet. Ano, parang magkapantay lang sila, magkatapat, pero hindi sila mag-meet. Never. Ano, parallel lang. Okay, so current in the same direction, the field strength in the space between the conductors is decreased due to the two fields there being in the opposition to each other. Hence, the two conductors are attached toward each other. So, pag sinabing field strength, ano nga yung field strength? Flux, beta, H, R, ano yun? Field strength is H. Nalimutan na. So sabi, ang field strength daw doon sa space between the two conductors is decreased. Okay? Dahil ang kanilang current ay in the same direction. Ibig sabihin, let's say, ito yung nagkita na mas malaking conductor. So, yan yung conductor natin, magka-parallel sila. So, yung current daw nila na nagpa-flow dun sa conductor na yun ay same ang direction. Let's say, current 1 here is flowing upward and also the current here. Ayan. So, I1 and I2 were the currents flowing at the same direction. Inside the two conductors. So that you will, if you're gonna get the total field strength, you will use this formula, decrease. That's why it's gonna be H1 minus H2. So, field strength of this first conductor minus the field strength of the second conductor. Okay, so that is for same direction of current. What if opposite direction of current naman? So, the field strength is increased in the space between the two conductors due to the two fields being in the same direction there. Mali. Bakit baliktad to?
Material that we are using right now nowadays sa ating mga residential, commercial sa schools, ay yung ating nakikita nyo sa natin.
Okay, so because of the lateral repulsion of the lines, of course, the two conductors experience a mutual force of repulsion. Bakit mali? Bakit baliktad? So, field strength daw. So, H total is equals to H1 plus H2. Wait lang. I need to clear something.
Reset check.
Yung doctor yan, nakaganda siya yung material ng
Wait a minute.
meron tayong material na nag-aano ng flow of electrons, meron naman tayong material na doesn't allow the flow of electrons. So ito yung tinatawag natin insulator. Siya yung ating example ng ating conductors. Sila ay made of materials generally
Tama naman. Pag opposite ang direction ng current, plus. Pagka same direction is minus. Okay, so that's correct naman. Nalito lang ako dun sa wordings sa ilalim. Okay, so that's it ha. When the current is in the same direction, the field strength is decreased. That's why it's gonna be minus. When the current is in the opposite direction, that is additive, plus. Okay. Next. Tatanggalin ko na yung mga sulat-sulat.
So that is our mga sample na natin sa meters, mga dimensionators. We have rubber, glass, diamond,
so magnetic forces between two straight wires with current. Okay, two straight wires with current. So to get that force between the two straight wires with currents, we will use this formula. F is equals to mu O mu R I1 I2 L over 2 pi D. Okay, where I1 is the current in amperes in the first wire and I2 is the current in the second wire. Then we have L, which is the length in meter. Then we have the D, which is the distance between the two conductors, and mu O, which is the constant permeability, which is constant 33 in MKS. MKS or meter, kilogram, and seconds na unit base. Okay, so that is your constant permeability or yung ating 4 pi times 10 raised to negative 7. Iisa lang yan ha. This one, 4 pi times 10 raised to negative 7 is iisa lang kay constant 33. So, nasa sa inyo kung gusto nyo sauluhin ang 4 pi times 10 raised to negative 7 or mag-constant 33 na lang kayo. Okay, then we have the relative permeability. Relative permeability again, if it is given, you will use that. If it is not, then you will use 1. Okay, and then the relative permeability of air, vacuum, and let's say free space, you will use 1. Okay, that is for the relative permeability. Okay, so in MKS, si mu O ay 4 pi times 10 raised to negative 7. You can simplify this formula. Okay? Diba? This will be 4 pi times 10 raised to negative 7 mu R I1 I2 L over 2 pi D. You can simplify this by dividing this 2. Cancel pi. 4 divided by 2 is 2. So this one will be 2 times 10 raised to negative 7 mu R I1 I2 L over D. Okay. So you can use this formula straight to the point na agad. Kumbaga, when all the parameters are in MKS units, you can use this straight na. Okay lang na wag ka nang dumaan dito. Just go here and you will get the same answer. Okay. Then, what is the unit for force in MKS? What is the unit? Newton or N, okay? In MKS. Okay. So, dapat makikita ko ito sa inyong formula book, okay? This one and this one and this one. Okay?
So next one naman before we start.
Okay, example. Ang gulo. Ang gulo ng buhay. Wait lang. Dito tayo sa kabila. Medyo madali ang buhay dito. Okay.
So, commonly, ang ginagamit sa physical training or technical engineering type, SID.
So, ito na pala yung sagot. Pero sagutan natin ng atin. Ito. Wait lang.
So, may mga ginagamit tayo ng kilo, deci, centi, micro.
Yan.
may mga
So, two straight parallel wires, 2 meters long and 3 millimeters apart, carries a current of 8 amperes in opposite direction. Calculate the magnitude of the force between these conductors. So, again, the formula for getting the force between two conductors or two straight wires, we have F is equals to mu O, or maybe let's use 2 times 10 raised to negative 7 mu R I1 I2 L over D. Yan. So that's the formula in getting the force between the two conductors. Then let's say the given or length 2 meters, distance 3 millimeters, and current 8 amperes. Okay, in opposite direction daw. That means you have two currents, which is 8 amperes. No, so we have I1 and I2, which is 8 amperes also. Okay, so yeah, using the given parameters, substitute that to your formula. So we have F is equals to 2 times 10 raised to negative 7. Okay, so note or take note that we will use this formula only when we are using it in terms of MKS. Okay, so you have to convert everything in MKS. So, anong mu R natin? Mu R, no given. No mu R is given. So, you will use 1. Then, we have I1 is 8, I2 is 8. Length is 2 meters over 3 millimeters. You have to convert this in exponential form, right? Because the unit is only meter, not millimeter. So you will convert it into exponential form, that is times 10 raised to negative what? Milli. Nasa basic EE nyo to. What is milli? Times 10 raised to negative
3 po.
Okay, negative 3, that's correct. Then, meter. Ano, matatanggal din naman tong meter na to eh, because of this. So, yan. Okay, so using our calculator, paki-input ako ng lahat ng ito. And what is the force between these conductors? Hello? Anong answer?
Make sure ko lang po, natandaan nyo pa yan. Kasi marami pa rin nagkakamali dyan kapag magaling na meter sa finance. Hindi alam yung conversion ng mega sa giga o micro.
Uy, pumindot kayo sa CalQ.
Nire-request ko lang yung finance.
Ha, next week, I will check if you have calculator and if you have your index card.
8.53
Okay? What?
8.53 times 10 raised to negative
8?
8.53 po times 10.
8.53. 4 decimal places.
Sino ba ang
5,333 po.
5,333 times 10 raised to
Negative 3 po.
negative 3 Newton. Okay, that's correct. Thank you po. Wait lang ha, lalaksan ko lang ang aking sounds at wala akong marinig. Aba, ay malakas pa pala eh. Gayon. Hindi na ng aking naririnig. Okay, so naiintindihan how to get the force or magnitude of the force between two conductors or two straight wires.
Ano ba ba nila?
So, ano ba yung hitsura ng two straight wires na yan? Parallel din siya, ha? Ganyan lang
Kilo
yun.
natin? 36 kilo.
This is your distance.
So, sa isang
Then, we have the length.
Sa 1 kilovolt natin, meron tayong equivalent na how many volts? We have 1,000.
And yung current natin. Opposite direction lang. Ayan, ganyan lang po ha. Okay, number 2. A coil of moving instrument
1,000 2.6 times 10 raised to 4,000 volts or 36.
A coil of moving instrument is wound with 250 turns of wire. The flux density in the gap is 0.085 Tesla, and the effective length of the coil side in the air gap is 5 centimeters. Find the force doing acting on each coil side when carrying current of 60 milliampere in dynes. So, in dynes daw.
Lagi silang tatlo, ano muna sa mga pagsasalit natin. May mga very active.
Okay, so lagay lahat ng given.
Any continue that, ano kapag sa...
Meron tayong N, which is 250 turns. Flux density natin is 0.085 Tesla. Effective length of the coil side is 5 centimeters. Then, current 60 milliampere. Force daw. Okay, so kung sa nakikita ninyo na given, anong gagamitin natin formula dyan? BIL. Di ba meron tayong formula which is F is equals to force is equals to B I Bill sine theta, right? And this is for MKS. When I put over 10 here, this is for CGS, right? Which is in dynes. Bakit po in dynes? Because yun ang hinihingi. That's the unknown force in terms of dynes. So we will use the formula which is in CGS because it's the force in dynes. Ano? Okay, so that means you have to convert everything in CGS. So this flux density, you have to convert it in Gauss, right? So Tesla to Gauss, 1 Tesla is equals to 10 raised to 4 Gauss, right? Okay, so you have to convert it. So we have 0.085 Tesla times 10 raised to 4 Gauss. 1 Tesla. Cancel Tesla. So anong ating? What's the flux density?
850 goes po.
850 Gauss. Ayan. So, the length is in centimeters, so that is in CGS. Then, the current is, you don't need to change that because current is in ampere always, given in MKS, CGS, and English. So, just substitute it in the formula. So, we have 850 Gauss. Current is 60, but milli, you have to convert it into exponential form. So that will be times 10 raised to negative 3 ampere. Then your length is 5 centimeters and sine. Okay, so if there's no given angle, just use 90 degrees. Okay? Automatic 90 degrees. If there's no given angle, use 90 degrees. Okay? Take note. Over 10. So what will be your force?
So next sa atin, pasok na tayo sa ating topic talaga. Sa ating third coverage ang ating topic.
What's the answer?
System ng ating
Is it 25.5?
System sa electricity. Meron tayong direct current system.
Hello, ah.
Alternating current system. So, ang ating
25.5?
direct
Dynes.
So, ano ba si direct current?
Is this your final answer?
Direct current.
Yes po, ma'am.
Okay, so this is the force, but this is not the final answer. Okay? Pagka ang hiningi sa inyo is force in dynes, okay, it should be a big value like thousands, like that. Ano? So if it is like this, 25.5, this is not yet your final answer. Okay. So, ay ano ma'am, paano pang gagawin dyan? So, this force is just for one turn. For one turn only. So, you have to multiply it in 250 turns of wire. So, this will be 25.5 times 250 turns. So, what will be the force?
6375 dynes po.
6375 dynes. So, that's it. Ano? Pag po ganito kaliit yung nakuha nyo, hindi pa yan yung final answer. Kailangan nyo i-multiply yan sa number of turns. That's why may given na number of turns dyan. Ano, nagtataka siguro kayo, saan gagamitin yung number of turns na iyon? So, you will use that here. Ano? You will multiply it in the force times number of turns. Okay? So, any questions? Okay, none. So, next tayo. Ayan. Next is reluctance. Wait lang. Tanggalin natin ang mga alibot-bot. Ang dami naman. Okay, so reluctance or R. So it is the property of material that opposes flux flow. Flux flow. So in electric circuit, ano yung nagfo-flow doon? Di ba current? In an electric circuit, ang nagfo-flow ay current. Ano yung nag-o-oppose ng current flow? Di ba resistance? So here, in magnetic circuit, yung nagfo-flow dito is flux. Ano, flux or phi. Phi yung nag-flow dito and yung nag-o-oppose ng flux flow is the reluctance. Okay? So, that is the difference between electric circuit and magnetic circuit. Okay? In magnetic circuit, the flux is the one who is flowing. Ano? And in electric circuit, it is the current. Okay? So, ayan. So, it is equal to the ratio of MMF in a magnetic circuit to the magnetic flux through any cross-section of the magnetic circuit. Okay? Ratio of MMF to the magnetic flux. That means that is MMF over flux. That is your reluctance. So, it depends upon the length, area, of the cross-section and the permeability of the material that makes up the magnetic circuit, and it is measured in ampere turn per Weber. Okay, so diba, MMF is equal to N times I. So flux is V. So Ni over flux, that is your reluctance. Okay? So how come nag-come up ka dito kay L over A mu O mu R? Okay, so
may time na siya ay negative, sabihin natin yan, 0.5 seconds. 0.5 seconds yung ating current to positive. So after that 0.5 seconds, another 0.5 seconds.
okay. So, ayan.
So negative to positive naman.
Diba meron tayong formula na B is equals to mu O mu R H. And we also have OBA.
Napapansin natin siya ay positive muna.
Right? May OBA tayo. So if you put this here, this one will be Ni over
negative to positive naman siya naman ay
B times A.
same figure tayo din natin.
Okay. And B or beta is equivalent to mu O mu R H.
Nakuha ba yung difference ng ating direct answer?
So Ni over mu O mu R
Kung si pattern
H.
nga pala ay
A.
sa direct answer system, yung ating mga
Right.
PCI na
And then,
yung mga
what
natin
else?
sa bahay. Yan po ay basic. Basic po yun po nasa bahay. Nasa sakar.
Excuse me.
Yung mga LEDs na natin, wala sa LED natin. Green light. Green light. Natin yung mga so easy naman.
Hindi pala, wait lang. Ni over L. Di ba si H is equals to Ni over L, right? Ano, which is the, wait lang po, pinatawag. Tanggalin natin tong Facebook.
Pasok tayo sa electric circuit.
Okay, so from this one, this is the field intensity in a solenoid, right?
Siya po yung
Saan
pinagbilan
ba itong akala na
ng
ito?
mga
Nakawa sa akin.
sa atin ng ating any branches na nagsisigil.
Saglit lang po, ha. So, ayan. So, from this one, ilagay natin si H, which is Ni over L dito. Ano? So, this one will be Ni over mu O mu R. H is Ni over L times A. So, cancel natin si Ni. So, this one will be 1. Ano? 1 over L. So, 1 over L, that is, mai-inverse siya kasi ito yung naka-1 eh. 1 over L, kaya po napataas si L dito. Pag nangyari, naging reluctance is equals to L over A mu O mu R, or mu O mu R A. Mas madali siyang banggitin pag gano'n na. So, ayan ha, this is your length or length of the material, then area of the material, then we have mu O or absolute permeability and relative permeability. Okay? So, ayan. So, in MKS, ang inyong unit is ampere turn per Weber. And in CGS, your unit is Gilberts per Maxwell. Okay? So, later, i-add natin siya sa table. Okay? So, ipunin nyo lang. Ayan.
Ay, nakapatay yung atin. Wala pong dadalhin yun.
Okay, so
Kaya ang ating electric circuit
Okay,
ay
so,
always.
pagka po ang given is in length, okay, so the given is length in terms of meter, okay, kumbaga straight to the point, binigay ang length, you will use that as your length. But if your given is in terms of diameter or radius, parang length is the circumference. So you have to use this L, which is equivalent to pi d, this one, or length is equivalent to 2 pi r. Okay? Again, if the given is in terms of diameter or radius, to get the length, you will use this one, pi d or 2 pi r. Okay? Okay, so yan. Next is permeance. It is the measure of the ease with which flux can be set up in the material. So it is just the reciprocal of reluctance of the material, and it is measured in Weber per ampere turn. So again, it's just the reciprocal of reluctance per means. So that will be P is equals to 1 over R. So that is, as in, tawag dito, literal. Literally, you will inverse everything, nanake-reluctance. So, if the reluctance is L over mu O, mu R A, so the permeance will be equal to mu O, mu R A over L. Okay? Just the reciprocal of the reluctance. And if the unit is in Weber per ampere turn per Weber, then the unit of your permeance is Weber per ampere turn. Okay? Literal na binaliktad. Reciprocal. Okay? So that is your permeance. Next is reluctivity. So the reluctivity is the reciprocal of your permeability. So if, wait lang, let's remove this.
Yan po sa electric circuit. Sa case natin sa mga para ma-repeat
Okay. So if your permeability mu, yan. Diba si permeability is equals to mu O, mu R. Okay? So, if reluctivity is the reciprocal of permeability, then you will have reluctivity is equals to 1 over mu O, mu R. Okay? So, if you will substitute reluctivity into reluctance, you can get this one. No, because it is equals to 1 over mu O mu R. So you can see here 1 over mu O mu R, right? Ayan. That means it is equivalent to reluctivity times length over area. That is your reluctance. Okay, so you can use this as your formula in getting the reluctance. Okay? Kumbaga, ini-insert sa reluctivity dito kay reluctance. Because may equivalent siya. Okay? Again, this is reluctance ha, hindi reluctivity. Reluctivity is like V. Ano V?
Instead na mag-flow yung ating electricity dito sa...
So, yan. That is your reluctance. Okay, so next is the comparison between the magnetic and electric circuits. So, although magnetic and electric circuits have many points of similarity, but still, they are not analogous in all aspects. So, a comparison of the two circuits is given below. So, as you can see, this is the magnetic circuit. circular siya. Okay, then we have here the wire na nakaikot. Kaya meron tayo laging number of turns. Because yun yung bilang kung gaano kadami mo iniikot yung wire doon sa coil mismo, sa ring. Then, dyan mo i-apply yung current mo. Dito sa dalawang, tanggalin nga natin ang red para mas makita. Oh, no.
So, since ang ating behavior ng ating electricity, ang ating electricity ay always mag-flow siya sa ating
so, from this
path.
One, dito mag-enter yung ating current, then dito siya lalabas. So, pag-apply ng current dyan, magkakaroon siya ng magnetic field. Okay? Then, in this ring, coil, so we have there the area, we have the, what else, the flux, the relative permeability, and everything na parameters na na-discuss natin. So, in electrical circuit, so you already know about this electrical circuit because you already took BS or basic electrical engineering, right? Then, we have here the source. This source is, I think it's battery. Then we have the conductor and the resistor. Okay, current is flowing there. Then the resistor is the one who is opposing the flow of current, right? Here, we have the reluctance who is opposing the flow of current. Okay. Then to get the resistance, we have rho L over A. Okay. Here, to get the reluctance, we will use L over mu o mu R A, right? So, ayan.
Kapag nakita nyo bumaba yung switch ng ating separator, ibig sabihin may short circuit na rin po. So, wala kung naka-open pa rin yan.
Okay, so, ayan. So, these are the similarities of the magnetic circuit and the electric circuit. So, the closed path for magnetic flux is called magnetic circuit, and the closed path for electric current is called electric circuit. Okay, so here in AC and DC machines, we're gonna use magnetic circuit. Okay, then we have here flux. Again, flux is MMF over reluctance. Wherein electric circuit, we have the current, which is equivalent to EMF or voltage over resistance. Then, flux is in Weber, current is in ampere. MMF is in ampere turn, EMF is in voltage. MMF is magnetomotive force, EMF is electromotive force. Reluctance is equivalent to L over A times permeability, or L over A mu o mu R, which is in terms of ampere turn per Weber. Here, the resistance is equivalent to R, which is equals to rho L over A. So this is resistivity, or R is equals to 1 over conductivity. Okay, so next is the permeance. Permeance is the reciprocal of reluctance. Here is, it is the conductance, which is the reciprocal of resistance. Next is permeability. Here is conductivity. Okay. Then we have reluctivity. The other side is resistivity. Flux density naman dito, or beta, is equals to flux over area in terms of Weber per m squared. Here we have the current density, which is J, equivalent to L over A, which is ampere per m squared. Magnetic intensity, which is H, equivalent to Ni over L. Electric intensity is E over, which is equals to V over D. Okay, so yan. Similarities. Pinakita lang naman dyan kung ano yung similarities ni magnetic circuit and ni electric circuit. Na meron silang equivalent kada circuit. Okay, so ito naman yung differences. So, in fact, okay, dito si magnetic ha. Magnetic. And here is the electric. So, in magnetic circuit, the magnetic flux does not flow, but it sets up in the magnetic circuit. Basically, molecular poles are aligned. Okay, so in electric, the electric current or electrons actually flows in an electric circuit. So, ayun nga, ang pinagkaiba nila is the magnetic flux is not usually flowing. It is just present there in the magnetic field. Here in the electric circuit, electric current is actually flowing. That is your electrons. That is the one who is flowing inside the electric circuit. Next, we have there is no perfect insulator. It can be set up even in the non-magnetic materials like air, rubber, glass, etc. with reasonable magnetomotive force. In electric current, there are a large number of perfect insulators like glass, air, rubber, etc. which do not allow it to flow or follow through them under normal conditions. That means in electric circuit, there are so many insulators, perfect insulators na hindi talaga magfo-flow yung current outside that insulator. Okay, in magnetic flux, there is no perfect insulator because even though there's an insulator, there is still magnetic field outside it. Kumbaga, hindi maiiwasan na meron pa rin na magnetic field outside ni insulator. Okay, next is reluctance of a magnetic circuit is not constant, rather it varies with the value of B or flux density. It is because the value of mu r changes considerably with the change in B. What does it mean? Diba? So reluctance is equals to L over mu O, mu r A. Okay.
So we also use this capacitor.
Okay. So the reluctance here changes. It's not constant because kino-consider si flux density. Okay? Pag nagbago or if there's a change in flux density, there is also a change in reluctance. Kino-consider si flux density. Then, in the electric circuit, the resistance of an electric circuit is almost constant as its value depends upon the value of the resistivity, which is almost constant. However, the value of resistivity and R may vary slightly if temperature changes. Okay, so resistor or the resistance in an electric circuit is always constant. Okay, mag-iiba man siya, very minimal. Minimal yung change. It is just because of the temperature outside. Next is, once the magnetic flux is set up in the magnetic circuit, no energy is expanded. However, a small amount of energy is required at the start to create flux in the circuit. While in electric circuit, energy is expanded continuously so long as the current flows through an electric circuit. This energy is dissipated in the form of heat. Okay. So,
ito daw si ammeter na riyan. Siya po ay
ayan, that's the differences between the magnetic circuit and electric circuit. Okay, so yan na yung comparison. Comparison yung similarities and differences. Okay, so we have two examples. Last two examples. Here in So, itong example na to, i-discuss ko later after nung isa pang mga formulas. Ano yung chapter 1, module 3. So, ito muna dito.
Sabihin natin meron tayong board.
Okay, so a certain laminated steel has a permeability of 3,000. The length is 5 centimeter and the cross-sectional area is 2 square meter. What is the reluctance? Okay, reluctance ang hinahanap. So, tanggalin natin lahat ng ito.
Sabi natin kanina, ang ating ammeter ay connected yung series sa ating
Okay. So first, i-identify lahat ng given parameters and all the unknowns. Parang ang daming unknowns. No? So given, we have here permeability of 3,000. Pag may binigay sa inyo na permeability which is ganyan kalaki, that is a relative permeability. So that is mu r. Okay? Hindi porket sinabi na permeability lang siya, mu na siya. Ano, hindi siya yun. Mu r yan. Okay? So mu r of the laminated steel is 3,000. So if it is 3,000, what kind of material? Saan siya na bagsak na types ng materials? Is it ferro, para, or diamagnetic material? Diba? Si ferro ay, mu r is very high. No, more than 1. Then in para, more than 1 only. And in dia, we have less than 1. So pag sinabing ferromagnetic materials, ang range niya is 50 to 5,000. Then, this is 49 below. Greater than 1. So let's say 2. Ayan. 2 to 49. And then, mu r of the diamagnetic material is less than 1. So this is negative. Ano? Basta negative numbers na, diamagnetic na siya. Negative 1. Okay, so laminated steel is a ferromagnetic material. Kasi ang mu r niya is 3,000, right? Next is length of the material is 5 centimeters. Cross-sectional area is 2 square meter. What is your reluctance? So, base sa formulas back there, reluctance is equals to L over mu O, mu R, A. So, we have a length, we have relative permeability, we have the area. What is the absolute permeability? Absolute permeability is constant 33. So, ibig sabihin, we will use MKS. So, we have 5 centimeters. In MKS, the length is in meters. So, you have to convert this into meter. So, this one will be 5 centimeter times 1 meter over 100 centimeter. Cancel centimeter over mu. O natin is constant 33 or 4 pi times 10 raised to negative 7. Okay? Mu r natin given, which is 3,000. Area is 2 square meter. So, it is in square meter. That is in MKS. So, lusot nyo na dyan. What is your reluctance?
So, back tayo sa ating ammeter. So, ito ulit naman natin si ammeter. Yung series sa ating series natin. So, ating natin dito ulit na natin.
Hello, what is your reluctance?
6.6315 po.
6.6315 times 10 raised to? Meron ba?
Wala po.
Wala ba? Ako meron. Ampere turn per Weber. So this one is your reluctance. Any questions?
Wala pong tanong.
Okay, so ayan, naintindihan naman. So dahil walang tanong, ibig sabihin, naintindihan. Okay. So ayan, that is for module 2. Again, I will discuss this later after the discussion of module 3 because it is about the formulas there. Okay?
Meron tayo dito circuit.
Okay.
Diagram. Ng ating computer.
Are you still there? Everyone? Yung sabi ko. So, itong module 3 natin is maiksi lang naman siya. Maiksi lang, ha? Ayan o, ilan ba ito? Ito naman ay ano lang, pagsusulatan ko lang. Tsaka, are. Sulatan ko lang yun. So, ano lang siya, 15 or 14 slides. Okay? Kasi ito naman, thank you na lang eh. Okay, so, so, carry pa ba? Okay, so all the formulas here inside this module 3, you will put this in your index card or your notebook or everywhere you want to put it. Okay, so this is about electromagnetic induction. Okay, so let's start. Okay, so Faraday's law. So meron tong video. Makikita nyo naman siya doon sa dito sa inyong Google Classroom. Ano yung module 3 may kasama yan na video. Ay, wala pa pala. Ilalagay ko yung link ng video, then panoorin nyo na lang. Ha, yun naman ay additional knowledge lang. Okay? Yun namang theory niya is i-discuss ko naman sa inyo. Okay, so yung video niya is panoorin nyo na lang. Okay? Pero mamaya na lang yan, ha? Para medyo bawas sa ating time. Kasi magta-time na mamaya. So, Faraday's laws of electromagnetic induction. So, Michael Faraday summed up conclusions of his experiments regarding electromagnetic induction into two laws, known as Faraday's laws of electromagnetic induction. So the first law states that whenever a conductor cuts across the magnetic field, an EMF is induced in the conductor. Okay? That means, so, di ba alam nyo na yung magnetic field? Ano, ito yung nandoon sa palibot ng magnet. Okay? So when there's a magnet, the north and the south pole, okay, let's say this is North Pole and this is South Pole. So, may magnetic field dyan. Ano, may magnetic field. Ganyan. Then, this is the magnetic lines. Then, we have the flux. Ano, flux niyan is nag-flow from North to South Pole, right? North to South Pole. North to South, North to South Pole. Kapag ka naglagay ka, if you put a conductor or a wire between that north and south pole, then you will cut flux. You will cut the flux and it will induce an EMF. So it will produce a voltage. That will generate a voltage. Okay? And you can use that to generate electricity. Okay? So yun po yung ginagamit in process of generator. Ano, there's a north and south pole na magnet, then there's a magnetic field, and there is a magnetic flux flowing there. If you cut the flux, you will generate an EMF or electromotive force. Okay, it is induced in the conductor, then it can generate electricity. Okay, so yun yung process ng paggana ng isang generator. Okay, so that is the first law. Okay naman. it also states that whenever the magnetic flux linking with any circuit or coil changes, an EMF is induced in the circuit. Okay, so yun naman yung nasa video. Ano, papapanood ko sa inyo yung video. Di pala, I will put the link there in your Google Classroom and then watch it if you have free time. Okay, that is an additional knowledge. Okay, so how did you or how can you get that induced EMF or voltage? How can you compute? Okay, so nandito naman siya sa second law. Okay, so this law states that the magnitude of induced EMF in a coil is directly proportional to the rate of change of flux linkages. Okay, so rate of change of flux linkages is equals to N, or number of turns, times flux 1 minus flux 2 over time. And that is in Weber turn per second. Okay, so that is your rate of change of flux linkages. Therefore, the induced EMF or voltage is equals to N times change in flux over change in time, and your unit is in volts. Ninaga na ang aking pen. Wait lang. Wala na yatang tinta ang aking pen. Wait.
Distance and time. So to measure that, change in x over change in rate.
Ala, ayan. Okay? So, induced EMF or the voltage induced in a magnetic field or magnetic circuit is equals to N times flux 1 minus flux 2 over time. Ito yung change in flux. Ano? Flux 1 minus flux 2. Then, your change in time is T. Or, pag binigay naman siya sa example is directly time na, and you will use that na. Okay? Okay, so again, N is the number of turns of the coil. Flux 1 minus flux 2 is the change of flux in terms of Weber. T is the time in seconds for the change. Okay, so ayan. We also have a formula in induced EMF, which is this one. So when flux linking with a conductor or coil changes, an EMF is induced in it. This change in flux linkages can be obtained in the following two ways. So we have flux cut over time, which is equals to flux over dt, and the flux is equals to BL dx over dt, where dx over dt is equivalent to velocity. That's why it became flux density times length times velocity. Okay, so BLV, and it is also equivalent to BLDX sine theta over dt, which is BLV sine theta. Okay, so BLV sine theta. So you will use this if you are based in MKS, and you will use BLV sine theta times 10 raised to negative 8 if you are in CGS. Okay, but even if it's MKS and CGS, it's always volts. Okay, the unit for E or induced electromotive force is volts. Ano kasi voltage yung kinukuha nyo dyan eh. Okay, so in MKS, we have Tesla for flux density, CGS is Gauss, English, we have lines per inch squared. Then in MKS, for the length, we have meters, CGS cm, English inch. And for velocity, in MKS, we have meter per second, CGS, we have centimeters per second, and in English, we have inches per second. Okay? Again, that is for voltage or induced EMF or induced electromotive force. Okay.
Si Ivan Carlos.
Okay, example number 1. A coil of 500 turns in linked with a flux of 2 milliweber. If this flux is reversed in 4 milliseconds, calculate the average EMF induced in the coil. Okay, so sagutan natin ang atin. Okay, so number 1, lagay ang given. Meron daw N na 500 turns. Meron daw flux. So, flux is 2 milliweber. And the flux is reversed in 4 milliseconds. So, that is your time. 4 milliseconds. Calculate the average EMF. So, E. E is the unknown parameter here. So, using this, using those givens, ano ang pwede mong maging formula? Diba? We have E is equals to N times D flux over dt. Or N times flux 1 minus flux 2 over time. Okay, so let's get the flux 1 minus flux 2. Kasi ang N natin 500 turns. Flux 1 minus flux 2. Ma, we only have 1 flux. Anong ilalagay natin sa flux 2? So, sabi, ni-reversed. Flux is reversed. If the flux is reversed, then your another flux will be just the same as the first flux, but in different direction or different polarity. So that will be negative 2 milliweber. So your flux 1 is 2 milliweber. Flux 2 is equals to negative 2 milliweber. Ayan. Okay? So, this will be 2 milliweber minus negative 2 milliweber. Or that means you will just multiply it by 2 because this will be negative times negative positive. So, this will be plus. So, parang nag-times 2 lang kayo. Then, your time is 4 milliseconds. Okay, so E is equals to 500. So, 2 milliweber minus negative 2 milliweber is equals to 4 milliweber over 4 milliseconds. Okay, so milli natin, di ba, times 10 raised to negative 3 lang yan. So, tanggalin na natin. Ano, kasi makakancel lang naman talaga siya. So, this will be 4 divided by 4 is equals to 1 times 500. Your average EMF is equals to 500 volts. Okay. Naintindihan? Is it clear?
Yes po.
Any questions? Okay. So, number 2. A coil of 250 turns is wound on a magnetic circuit of reluctance 100,000 ampere turn per Weber. If a current of 2 amperes flowing in the coil is reversed in 5 milliseconds, find the average EMF induced in the coil. Okay, so let's have very large spacing. Natanggal siya. Kuhanin na natin, lipat natin sa kabilang ano. Okay, so again, get all the given parameters. And 250 turns. We have the reluctance of 100,000 ampere turn per Weber. Current natin is 2 amperes flowing in the coil and it is reversed in 5 milliseconds. Find the average EMF. So, E ulit. Okay. So to get ano ba? To get the average EMF, we have to use this formula N d flux over dt, right? Which is equals to N times flux 1 minus flux 2 over time. But based on the given parameters, we don't have flux. We only have reluctance. Nauutal na ako. We only have reluctance. Okay? So, what are we going to do? Okay. So, anong gagawin natin? So, di ba we have this formula? Reluctance is equals to MMF over flux. MMF is equals to N times I over flux. So we have N, we have I, we have reluctance, but we don't have flux. So, yun na yung chance nyo. Kuhanin nyo siya. Okay? So, itaas nyo lang si flux, ibabaan nyo si reluctance. So, this will be flux equals to Ni over reluctance. So, this will be N, 250 turns, times I, which is 2 amperes, over reluctance na 100,000. So, we are gold. Charis. O, anong ating flux? Anong flux natin? Are you gold? Ay, ulo! Anong inyong nakuha?
Okay na ba?
5 times 10 raised to negative 3 po.
5 times 10 raised to negative 3 or 5 times 10 raised to negative 3 Weber or 5 milliweber. Ayan. So, meron na tayong flux. Now, we can get the induced or ayan. We can now get the voltage or average EMF. So, E is equals to N, 250 turns. And then, again, ma'am, what is our flux number 2? If our flux number 1 is 5 milliweber, what is our flux 2? So, sabi dito, it is reversed again. So, we have negative 5 milliweber. Okay, so this one will be 5 milliweber minus negative 5 milliweber. Over time is 5 milliseconds. So, E is equals to 250 times, this will be plus, right? 10 milliweber over 5 milliseconds. So, tanggal si milli, remove the milli, 10 divided by 5 is 2. So, 250 times 2 is 500. So, we have 500 volts. This is our average EMF or average voltage. Any questions?
Wala po.
R4 naman at saka
Okay, so ayan. Okay na. Ayan. Next is we have this self-inductance. Okay, so this is the property of a coil due to which it opposes the change of current flowing through itself is called self-inductance or inductance of the coil. So, hindi nito hinahayaan na magbago yung current na nagfo-flow sa isang coil. Ano that is? Or sa coil or sa mismong kanyang coil. Okay? So, that is self-inductance. So, to get that self-inductance, we can use this formula. L is equals to mu o mu or A N squared over L. So, ang unit po ni inductance is Henry. Henry, or capital letter H. Okay, so we
J
also have this formula, which is L is equals to N times flux over I. Karen for the I, N is the number of turns, and this is flux. Then, what else? Meron pa, madami pa yan. Pakidagdag ako ha. Please put these formulas in your formula book, in your ano pa ba? We also have L is equals to N squared over R total. R total is total reluctance. We have number of turns, naka-squared. Okay? Lahat yan ay Henry ha. Mapa MKS, mapa CGS, Henry po ang kanyang unit. Okay?
Ilan natin mapapansin dito?
Ano pa? Dami niyo eh.
Pwede natin tawagin na short. So, ito ay pwede natin siya ma-simplify na. Ganito.
Ayun lang pala.
Pwede natin siya ma-short set.
Okay, so that is self-inductance. How about mutual inductance? So it is a property of one coil due to which it opposes the change of current in the other neighboring coil is called mutual inductance between two coils. So if there is two coils present, okay, mutual inductance is the property of the other coil na nag-o-oppose ng change ng current doon sa kabilang coil. Okay, so to get that mutual inductance, we have mu O mu R A, N1, N2 over L. Okay, so we have area, number of turns in the first coil, number of turns in the second coil, and the length of the coil. Meron pa ba tayong other formulas?
So, yan yung ating voltmeter sa ammeter na connection sa ating.
Oh, ang dami pa pala.
Gumamit ganyan sa...
Okay, so to get that mutual inductance, we also have here N1 times N2 over reluctance. Okay, so you can use that also in getting the mutual inductance. So that is inductance pa rin, so H pa rin siya or Henry. Ayan, kukulang. Henry or capital letter H. That is the unit of
So next naman
inductance.
what we do naman ay instrument
Okay.
for the measurement of water.
So again, saan manggagaling si mu O? That is constant 33 or 4 pi times 10 raised to negative 7 in MKS. Okay, so ang ano ko na lang sa inyo, ang paalala ko na lang sa inyo, mas madali po talagang gamitin ang MKS. So, doon na lang kayo mag-base sa MKS. Always use MKS. Depende na lang kung ang hinihingi sa inyo ay in CGS form, you can convert it naman.
Ating current coil ay connected in series.
This is length ha, in meters.
Then yung ating mga voltage pressure.
Okay, next, series magnetic circuit. Anong oras na? May time pa ba tayo? Oh, we still have time. So, series magnetic circuit. So, a magnetic circuit that has a number of parts of different dimensions and materials carrying the same magnetic field is called a series magnetic circuit. So, such as series magnetic circuit is shown in the figure. So, as you can see here, we have different there's different kinds of materials, also different dimensions. But they are in series. Kumbaga, magkakadikit nasa sa isang coil. No, nasa sa isang sila. Tawag dito. Nasa isang wire. Diba? Ito yung wire, which is nakaikot sa kanila. Okay? So, ayan, as you can see, we have only one current flowing there. Then we have only one number of turns because iisa naman sila naman ay magkakasama dun sa inikot na yon, di ba? But we have different dimensions, different areas, different lengths, okay, different permeability because they are different in materials. Ano? So, ayan. That is an example of a series magnetic circuit. Okay. So, in series magnetic circuit, we have different formulas na pwede niyong gamitin. Okay, so we have here total reluctance. So to get the total reluctance in series, you just have to add everything. Additive siya. Reluctance per material. Okay, so R total is equals to R1 plus R2 plus R3 plus R4. Okay, so material 1, material 2, material 3, and so on. Kahit gaano kadami yan, i-add nyo lang siya. Okay? So, siya ay and so on. Okay, so you just have to put their respective formula. So we have R1, which is L1 over A1 mu O mu R1. Dahil constant naman si mu O or absolute permeability, wala na siyang number. Kasi constant naman, no? Which is 4 pi times 10 raised to negative 7 in MKS. But in CGS, you can use 1. Okay. Constant. MKS, 4 pi times 10 raised to negative 7. In CGS, 1. Okay? So that is your R total. Then, to get the total magnetomotive force, di ba may formula tayo, which is R is equals to MMF over flux. So, ito yon si MMF. Okay? So, kuhanin nyo lang yung formula ni MMF, which is R times flux. So, this is So, paki-apply na lang ni R total dito, which is ito. Ito siya, di ba? So, we have flux times R total. Okay. So, this is another formula for getting MMF. This one is for R total, this is for MMF or magnetomotive force. But in case na ang given sa inyo ay in terms of flux density or beta, you can use this formula naman. So, di ba si flux is flux density times area. So, apply mo dito. Substitute mo siya. Then, distribute sa loob. Distribute nyo. Then, that will be B A L1 over mu O mu R 1A1, right? Makakancel si area. That's why, ang nangyari, naging B1L1 over mu O mu R1. And so on. Okay, kaya po, nakuha si itong formula na ito. Another formula. Depende naman yan kung anong gagamitin nyo, ha? Kung anong gagamitin nyo ay depende kung ano yung given. But this is also a valid formula. Then, meron tayong formula ni B na mu O mu RH. If you will replace this by mu O mu RH, this one will be mu O mu R H L1 over mu O mu R. Yan. So, makakancel to, di ba? Kaya nangyari naging H and L na lang siya. So, H1L1 plus H2L2 plus H3L3 and so on. So, you can use everything na nandiyan dyan, ha? Okay. Depende na lang kung ano yung given sa inyo. Okay. So, that is for series magnetic circuit. Okay. Example. A magnetic circuit, ito na yung ito na yung sabi ko kanina sa inyo na i-discuss ko ngayon. Yan. A magnetic circuit consists of silicon steel of 3,000 permeability and air gap. The length of steel core is 10 centimeter and the air gap is 2 centimeter. Both have the same cross-sectional area of 1.5 square meter and a current of 1/2 ampere flows through the windings to produce 2,351 Maxwell. How many turns are there in the coil? Hello?
So, after siya dapat
Hello, are you still there? Still listening?
Yes po.
Still awake? Okay. Okay, so,
Yes po.
sabi, ayun. Iimik kayo ha, para alam kong nandyan pa kayo. So, yun daw magnetic circuit ay kinakonsist ng dalawang, kung ano man yung dalawa na yun. Ano? Yung isa ay silicon steel, yung isa ay air gap or air. So, that means dalawa yung content ng magnetic circuit. So, yung silicon steel daw ay may permeability or mu R na 3,000. Mu RS, parang mu R ng steel. So, ano ba ang mu R ng air? Diba 1? Ano? Mu R ng air ay 1. So, the length of steel core naman daw, length of the steel is 10 centimeters. And the length of the air gap is 2 centimeters. Both have the same cross-sectional area. That means A or area ng steel is 1.5 square meter and ang area ng air is 1.5 square meter. Then we have a current of 1/2 ampere, so that is 0.5 ampere. And the windings, and it flows through the windings to produce a flux of 2,351 Maxwell. So, ayan. Dapat alam ninyo kung ano yung binibigay sa inyo. So, walang sinabi na flux density, pero may binigay naman na unit. So, ano ba yung Maxwell, di ba? Flux yon, di ba? So, 2,351 ang flux natin. Okay, so, how many turns are there in the coil? So, N daw ang hinahanap. Okay, so, using this given, ano yung hinikinita ninyo na formula na pwede nyo gamitin? Okay, so, N ang hinahanap.
Yes, bench. 9.81.
Yeah.
Wait, let's say, ang gawin natin, lahat ng...
Diba, to get N, meron tayong formula, yung pinakamalapit na formula dito na may mga permeability, ganun, is reluctance is equals to Ni over flux. Tama? Kasi meron tayong current, meron tayong flux, and ang hinahanap, pero wala tayong reluctance. So we have to get the reluctance using all of this given parameters. So meron tayong dalawang content ng magnetic circuit, so that will be R total equals to R1 plus R2. Yung R1 natin, gawin natin R sub S para sa steel. And yung isa naman is R para naman sa air. Yan. So this one will be L S over mu O, mu R ng S, A ng S, plus L ng air over mu O, mu R ng air, area ng air. So anong length natin ng steel? So again, madali ang MKS. So mag-MKS na lang tayo. Kasi naka-M squared na to, ito na lang yung i-convert natin. So mag-MKS tayo. So ang tawag dito, i-convert natin. 10 centimeters will be equal to 100 centimeter into 1 meter, right? So cancel cm. Divided by, anong mu O natin in MKS? 4 pi times 10 raised to negative 7. Mu RS natin given 3,000. Area ng steel, we have 1.5 square meter. We don't have to transform it into MKS because it is already in MKS. Plus, then we have length ng air, we have 2 centimeters times 1 meter into 100 centimeter. Cancel this, we have meter. So, 4 pi again times 10 raised to negative 7. Then what is the relative permeability of air? We have 1. Then what is the area of the air? 1.5 square meter. So what will be your total reluctance? Input naman sa calculator.
10,628.0134 po.
013
4 po.
sa pa? Ha?
4 po, 4.
4. Ayan. Which is ampere turn per Weber. So that is our total reluctance. So now we can use this formula na because we already have total reluctance. But we need to convert this flux into what? Into what unit? Because we're using MKS. What unit? Hello? Into Weber. Okay? So, pakibalikan ako ng mga ano nyo ha? Ng mga units. So, meron tayong conversion na 1 Weber is equivalent to 10 raised to 8 Maxwell. So, convert lang natin. So, 2,351 Max times 1 Weber, 10 raised to 8 Maxwell. So, what is our flux? 2.351 times 10 raised to, ano? Negative 3, negative 5, negative?
Negative 5 po.
5. So, we have negative 5. Okay, so, now that we're complete na, so, lagay na natin. So, 2,628.03 or 0134 equals to N times I na 0.5 times over 2.351 times 10 raised to negative 5. So, what's the number of turns? Ano gagawin nyo dito? Itaas nyo to, i-multiply nyo dito kay R total, ibaba nyo are, i-divide nyo dito. Para maiwan lang sa kabilang side si N. Ano ang ating N? Maliit lang yan. Hello, hello, hello. Everybody, hello.
0.4997 po.
997 turns. But wala naman tayong ganyan na turn. So, we will approximate it. So, approximately that is 1 turn. Okay? So, itataas nyo siya sa next higher whole number. Next higher whole number. Let's say we have 1.2 turns. So, that will be approximately 2 turns. Okay? Yung mga point niya, anong tawag dito? I-round off nyo to the next higher number or next higher whole number. Okay? Kahit pa 0.1 lang yan, kahit pa 0.2 lang yan, 0.3. You will itaas nyo. Itaas nyo. Okay, any questions? So, ito pala yung ating final answer. Oh my God, ang dami pa. Time na.
Ay, tulong talaga kasi yung pamilya.
Ayan.
Nakakatulong yan sa atin.
Ito naman ay madali na.
Masabi siya sa tulong.
Okay, so inductances in series and parallel. So two coils may be connected in series in the following two ways. First is when their fluxes are set up in the same direction. Fluxes daw ay nasa same direction, additive yon. And the inductance of each coil is increased by M. That means your total inductance is equals to L1 plus L2 plus 2M or two mutual inductances. Okay, naintindihan? Kapag ka naman daw ang inyong fluxes ay in opposite direction, that is subtractive and your inductance of each coil is decreased by M. That means your L total is equals to L1 plus L2 minus 2M. Okay, inductance 1 plus inductance 2 minus 2 mutual inductance. Okay, that is for the inductances in series, connected in series. How about in parallel? So in parallel naman, kapag ka same direction, when the fields or MMFs produced by them are in same direction, ibig sabihin, yung flux naman daw ay same direction in parallel connection, your total inductance is L1, L2 minus M squared over L1 plus L2 minus 2M. L is inductances and M is mutual inductance. Then, L total, syempre Henry pa din yan. Ano Henry? Or capital letter H. Basta inductance ang hinahanap, Henry ang kanyang unit. How about in opposite direction? Kapag ka daw parallel, tapos opposite direction ng flux. So your total inductance will be equal to L1, L2 minus M squared over L1 plus L2 plus 2M. Again, Henry pa rin yan. Okay, so any questions about this series and parallel inductances? Yan naman ay, kung magbibigay ako ng ganyan, ay direct substitution lang, ha? Bibigay ng L1, bibigay ng L2, kuhanin yung same mutual inductance, then get ang total inductance. Okay, next. Ayan, example na tayo. Example number 1, find the electromotive force in a conductor of length 50 centimeters moving perpendicular at a velocity of 590 meters per second. What is this? Is it a velocity? So, pag may velocity, alam nyo na agad kung anong formula. BLV sine theta. Okay, so meron daw tayong flux density na 1 Tesla. Oh my God, the chaos. Ano daw ang length? 50 centimeters. Perpendicular daw. What do you mean by perpendicular? What's the angle? What's the angle? Perpendicular. Pa-L.
90 po.
90 degrees. Then the velocity is 590. Hala, nawawala na yung tinta ng ballpen ko. Then, what else? Flux density, 1 Tesla. So, E, sabi electromotive force daw. So, E is equals to BLV sine theta. We will use MKS. Okay? So, B is 1. Anong length natin? 50 centimeters. So, you have to convert it into MKS because it is still in CGS. So, 50 centimeter, that will be 0.5 meters, right? Anong velocity natin in terms of MKS na dahil naka-meters per second na siya? So, 590. Then, we have sine 90 degrees. What is our electromotive force or voltage?
295 po.
295. That's correct. 29. Ala, putol-putol. 295 volts. Okay? That is our final answer. So, di ba madali lang? Ano lang, direct substitution. Ang kalilituhan nyo lang dyan is, i-convert ko ba to? Or converted ko siya? Ito na ba yan? Ito na ang gagamitin ko? Okay. So, next example. A magnetic coil produces 100,000 Maxwell with 2,000 turns and with a current of 2 ampere. The current is cut off and the flux collapses in 0.01 seconds. What is the average voltage that will appear across the coil? Pag average voltage, anong formula? E is equals to ND flux over dt. Yan ha, basta average voltage yan ang formula natin.
Ano yung initial?
So, let's get all the given parameters. 100,000 Maxwell, ano yun? Di ba flux yun? Naka-Maxwell. Meron tayong N which is 2,000 turns. Current natin, 2 ampere. Current is cut off and the flux collapses. Flux collapses in 0.01 seconds. What is the average voltage that will appear across the coil? Okay. So again, sabi ko nga sa inyo, gamitin natin yung MPS. Okay? Ibig sabihin, si Maxwell i-convert into Weber. Again, anong conversion? 1 Weber is equals to 10 raised to 8 max. So, convert natin siya. We have 100,000 max times 1 Weber over 10 raised to 8 max. What is our flux?
Therefore, ang iwain natin ay negative
1 times 10 raised to negative 3.
Happy Valentine's! Anong flux natin? 1 times 10 raised to
Negative 3 po.
negative 3? Weber na. Weber. Or 1 milli. Wag na pala. Nakaganyan na lang siya. Bye-bye! Happy Hearts Day! Wait lang, may tumawag kasi. Ayan, so we have E is equals to N. So we have 2,000 turns. Then, ganito. Di ba may binigay na tawag dito, flux? Sabi, the current is cut off or kinut off daw ang flux. And it collapses in 0.01 seconds. That means, kinut off ang flux. Wala kang flux number 2. You only have flux 1. Kasi kinut off na nga siya, pinatay na yung current. Okay, ibig sabihin, yung sunod mong flux ay 0 na, di ba? So, ibig sabihin, huwag mo na siyang ilalagay. Ang ilagay mo na lang ay yung flux number 1. So, that is 1 times 10 raised to negative 3 Weber. Yun na lang. Huwag mo na ilagay yung 0 or minus 0. Okay, kasi nga, kinut off siya. Hindi naman siya nag-reverse, di ba? Kung nag-reverse, magma-minus ka ng negative nun. Pagka nag-cut off, only 1 flux na lang yung ilagay mo. Over yung time na 0.01 second. So what will be your average voltage? $200 volts ba?
Opo.
Okay, so we have 200 volts. That is your average voltage. Any questions?
Wala po.
None po? Naintindihan?
4.03.
Okay, so paki-take note ako ha. Take note all the things na wala dyan sa module na sinasabi ko. Okay? So, ayan. That's all. And that's the end of Module 3. And that's the end of Chapter